Right. So to just summarize what we did in this chapter, it's a very long chapter. Sometimes it might be complicated, but this is essentially what we did. We introduced a simple concept called simple attention. We just introduced a very simple attention. It didn't have any untrainable weights, no trainable weights. So it had untrainable weights. It didn't have any trainable weights, right? We're using those alphas, and the alphas were being applied directly to our inputs in order to calculate the context vectors. That's what we did, right? But then we were like, but when we want to train, we actually want to train the weights that create these context vectors. So at least the performance is better. It is contextual to what we're doing. So we introduced trainable weights. We introduced trainable weights. And when we introduced these trainable weights, we introduced three matrices: WQ for queries, WK, and then WV. And these, when being applied now to our input, so our input gets applied here, and what we end up with is a queries matrix, a keys matrix, and a value matrix. And these two were used to create our attention scores, and then our attention matrix, attention weight matrix after attention weights. And then after that, our attention weights, we're using softmax with our square root of the dimension, with the square root of the dimension. That's how we normalized. And then when we then applied them to this vector, and we created our context vectors. And we said these weight matrices, they're parameters that are going to be tuned during training. But then we said, hold on. In large language models, they predict the next word by knowing what has happened prior and the word that is there now, but they do not know anything in the future. So we then added masks here. We added masks and we created our masked attention weights. We had the same thing with our WQ, WK, WV matrices, but then we applied masks because that's what we wanted to do. Applied masks so that we create a diagonal matrix, a matrix where the top diagonal is ignored, because we want to make sure that the tokens that are in the future are not seen by the model. And we also added dropout just to improve, so that we try mitigate against overfitting. Then we then went on to introduce, we're like, okay, cool, we are happy with what is happening here, but we want to parallelize it, that operation. To do it in parallelization, in parallel, so we introduce parallelization. And we first just did stacking. We did stacking with a for loop, with a for loop where the input was being worked on by this causal attention multiple times. But we saw that was not efficient. So what did we end up deciding to do? We then ended up saying, let's let's build big matrices where we can do one matrix multiplication per operation, and then we just then split those out into the number of years that we want, and we can work with those splits. But as long as we have been efficient in our matrix multiplication, because it turns out that matrix multiplication operation is very, very computationally expensive, and it is one of the most, if not the most, computationally expensive part of a matrix, of an LLM. When we're doing the training, it's computationally expensive. So if we can only do it once, happiness, we are happy. And then we just split them like that. So that is the summary of this chapter. Long chapter, but everything was building on top of each other, building on each other, building on each other, until we got to multi-head, which is what large language models use. They use the multi-head attention using parallelization. Like I mentioned, some of them have 96 heads. So when you read that this model is having 96 heads, that's essentially what they're doing, what they're explaining, what they're saying, or what they're doing there. Great. This is the end of this chapter. Again, congratulations. If you've gotten to this chapter and sort of picked up some stuff, you can go back to the chapter and analyze again what we're doing. What exactly did we mean by attention heads? GPT-2 model that we are going to be talking about, it had 25 attention heads with a vector embedding of 1,600. So those are big, big matrices, and we are going to see it. Now going to start touching the actual GPT-2 model. But this is how it was built, and that's how it was trained. And the attention, the multi-head, is because of the 25 heads it had. If you've understood anything in this chapter, congratulations. We know that this is a very complicated chapter, especially someone who has never done matrix multiplication. And then on top of that, we add PyTorch, which is complicated. But I do hope that you understood something. In the next chapter, we are now going to implement a GPT model from scratch to generate text. That's exciting. Now we are going to see these models in practice. How do they generate text? We are going to see that. We are going to see that now. And what's also exciting is we're going to get into loading weights and all of that stuff. But let me not preempt it because this is a long chapter. So let me not prolong this summary here. So stay tuned, and I'll see you in the next chapter.